the water planet. Third from the Sun, and the only planet in the solar system where water exists in liquid form. In fact, 3/4 of the Earth's surface is covered with it. Yet millions of people struggle to find enough water to survive. With the world's population growing by about 90 million people every year, the supply of usable water just isn't keeping up. Usable is the key. The overall amount of water on the planet never changes. It's only the distribution of it that varies. As a liquid on the surface or below it. As a vapor in clouds. Or as a solid at high altitudes and in the higher latitudes. Making sure we have enough water in usable form and getting it to where it's needed is what water management is all about. Conservation is one method. Using less water whenever possible. Building dams, reservoirs, and aqueducts. Cleaning up polluted water. And recycling water, especially for irrigation. Desalination, or desalting, is another method of increasing the supply of usable water. To most people, desalination means desalting seawater, unlocking the ocean's vast liquid treasure. Desalting seawater requires a lot of energy and has not been the top priority in the United States. It has been widely used in the Mideast, where the abundance of oil means inexpensive energy. But there's another use for desalination which is more practical and has just as much potential. By removing salts, minerals, and other contaminants, it can raise the quality of inland water supplies for use as drinking water or for irrigation. Desalination isn't new. In the 4th century BC, Greek sailors used evaporation to desalt seawater. Today, not only ships at sea, but entire cities use desalination to produce safe drinking water. Like this facility in Saudi Arabia. Exactly how does desalination work? There are several methods of removing salt, minerals, and other contaminants from water. One of the most common is distillation. Water is heated to the evaporation point, which turns it into a vapor, leaving salts and other minerals behind. Condensation converts the vapor back into a purified liquid.
The major players in the desalination game in the world today can generally be divided into two different camps, one being those that promote the use of distillation and those that promote the use of reverse osmosis, which is a membrane process.
Instead of heat, reverse osmosis uses pressure to remove salt and other minerals. Water molecules are forced through a special membrane under pressure, leaving the minerals behind.
This is a reverse osmosis membrane made on continuous membrane casting machine. The white film on the surface of the membrane is the thin polymer that allows water to pass and rejects salt. The white film is cast onto an unwoven carrier, which gives the membrane strength. This is a real spiral. As we unroll the contents of the element, we have the screen, a piece of the membrane. This then is the product water carrying material that collects the pure water that passes through the membrane sheets, and another piece of the membrane. Water passes through this membrane into this product carrying channel, and also through this membrane into the product carrying channel. The product water then passes spirally around until it enters into the small holes that were drilled in the product water tube and is collected out the end.
A third method of desalination is electrodialysis. Two types of membranes are placed between pairs of electrodes. Positively charged ions, such as calcium and sodium, pass through the first membrane. Negatively charged ions, such as chloride and sulfate, pass through the second membrane, producing fresh water.
The new areas that of membrane development will be in the area of gas separations and also in improving water separations as we have them today. Membranes that are more selective to specific ions, membranes that have more productivity, membranes that are more resistant to oxidation, so we can use strong sterilants like chlorine, hydrogen peroxide, membranes that resist fouling. All of these improvements will help reduce the costs of producing water.
The war in Kuwait brought world attention to the giant desalination plants in the Mideast. But in fact, Kuwait has been desalting seawater since 1949. The first desalination plant in the U.S. was built in Key West, Florida in the late 1960s. Today, the United States has the largest number of desalination plants, most of them treating groundwater in Florida, California, and Arizona. The largest facility for desalting seawater in the U.S. is in Santa Barbara, with a capacity of 6.7 million gallons a day. Catalina Island has a smaller facility, which treats 132,000 gallons a day. But Saudi Arabia produces the greatest volume of desalted water by far. The output of the Saudi Arabian facility at El Jubail alone is more than all the facilities in the U.S. combined, treating about 280 million gallons of seawater a day.
It's very obvious that the countries who have embraced the desalination processes are those in very arid parts of the world, particularly the Middle East. One of the first plants was built in Kuwait. Other major players, as far as countries are concerned, are Saudi Arabia, Bahrain, and others. Now, those countries utilize desalination processes in major sized plants. The largest being El Jubail, which is greater than 250 million gallons a day of capacity at one location.
As the soaring world population outpaces the world's supply of usable water, interest in desalination is growing fast. In 1960, the worldwide capacity for desalination was 50 million gallons a day. Today, the world capacity is more than 4 billion gallons a day.
Obviously, population growth all over the world is going to increase the need for fresh water and is going to increase the demand for desalination. Here in the state of California, we have an influx of approximately 500,000 new people in the state per year. Now, each of those individuals will consume, on the average, something like 50 to 100 gallons per day of water. The same type of growth is occurring throughout the Sun Belt of the United States, and I'm sure that same kind of growth is being experienced in other parts of the world.
The largest facility in the U.S. is the reverse osmosis desalter in Yuma, Arizona. Instead of seawater, irrigation runoff is being treated here. Nitrates and other agricultural byproducts are being removed from the runoff before it enters the Colorado River. South of Los Angeles, the Orange County Water District has been using desalination to help meet the demands of the 2.5 million people who live there. Water Factory 21 uses reverse osmosis to treat and recycle wastewater from municipal and industrial sources. After raising the quality to drinking water standards, it's being pumped into the groundwater basin along the coast to prevent seawater from seeping in. Around the U.S., New methods are being developed to remove objectionable organics, which can make membranes less efficient. New types of membranes and methods of extending the life of membranes are being developed and tested. The result will be a process that is more efficient and consumes less energy.
The new technology in membranes will lead to improved efficiencies as we know today, and also lead to many different separations that aren't available to us today in membranes. As membranes become more durable and more efficient, we'll be able to push into areas of separation that are not now available for current state-of-the-art membranes.
In addition to that, some great advances need to be made in the pre-treatment of water to be treated with reverse osmosis or electrodialysis. I think that would certainly advance the state-of-the-art.
Some of the substances that we will be able to deal with improved membranes will be higher nitrate removals, which are a problem in many areas of the country today. Removal of hazardous waste from groundwaters, such as chlorinated hydrocarbons, and those types of areas.
One of the large deterrents to more widespread use of desalination, particularly on the coast, is the fact that it is not a well-used process at the present time. It's not as widely used, for example, as utility plants are for generating power. As a result of that, people are unsure of the kind of waste that may emanate from a desalination plant. They're concerned about the environmental aspects of what impacts desalination plants might have on the coastal regions. Naturally, a very good question to ask at this point in time, but those of us that have been in the industry for many, many years will all agree that the kinds of waste that do come from a desalination plant are largely very, very benign, and we do not feel that there will be major environmental impacts from these desalination plants.
Whether it's used to treat seawater, wastewater, or brackish inland basins, it's time to reevaluate the enormous potential of desalination. The world's supply of usable water is being overwhelmed by its rapidly growing population. By conserving, desalting, or recycling, the only place to find more water is the water we already have.